Hello everyone, so we are back again with another video, and for today's video we will be discussing the third type of our partial fraction, which is the distinct quadratic factor. So in solving distinct quadratic factor, we need to remember, we need to note that if the fraction in the denominator is in the form of ax squared plus bx plus c, in which b squared minus 4ac is less than 0, we need to assume the partial fraction a times 2ax plus b all over ax squared plus bx plus c, where a and b here is the constant unknown number that we need to solve later on. Now, for example, we have here evaluate integral of x cubed plus 10 dx all over x cubed minus 2x squared plus 5x. Now, as you can see, our denominator here is, the exponent of our denominator here is cube. So meaning to say, we still need to transform this one in order for us to get the denominator in the form of ax squared plus bx plus c. And also, you need to note that the denominator and the numerator's exponent must not be equal. The exponent of our numerator must be less than the exponent of our denominator. But as you can see, in our example, the numerator and the denominator has the same exponent. So meaning to say, before we continue to our partial fraction, we need to simplify our equation first. Now, how can we simplify our equation? So as this is a fraction, so meaning to say, we can simplify this one by dividing the polynomials that we have using long division. So in using our long division, we can simplify our equation. So we have x cubed minus 2x squared plus 5x divided by x cubed plus 10. Now x cubed divided by x cubed, that is equal to 1. And 1 times x cubed, that is equal to x cubed minus 1 times negative 2x squared, that's negative 2x squared. 1 times 5x, that is positive 5x. Now I need to move this plus 10 here at the further side, since this is a constant number. Now afterwards, we need to perform our subtraction here. So x cubed minus x cubed, that is 0. 0 minus negative 2x squared, that is positive 2x squared plus 2x squared. 0 minus positive 5x, that is negative 5x, and then we need to bring down our constant, which is 10. So basically, this is now our remainder, since we cannot divide this by, we cannot have this divided by x cubed minus 2x squared plus 5x. So to write our remainder, we just have to add this to our quotient. So we have 2x squared minus 5x plus 10 all over this one. So we have x cubed minus 2x squared plus 5x. So basically, this quotient now, we can already replace our equation by the quotient that we have. So basically, we can rewrite this equation as equivalent as 1 plus 2x squared minus 5x plus 10 all over x cubed minus 2x squared plus 5x. Then we have the dx. Now, as you can see, it is separated a with an operation in between. So basically, we can integrate this separately. So we have the integral of dx plus the integral of this fraction. So we have 2x squared minus 5x plus 10 all over our x cubed minus 2x squared plus 5x, and then of course we have the dx. So as we know, the integral of dx is already x, so it's better to just put this aside for now, and then we have to deal with this complex fraction here. Now, as you can see, our denominator is still in the power of 3, so meaning to say we can just factor our denominator here just so we can come up with this form. So for this one, we just have to copy that one. So we have 2x squared minus 5x plus 10, and then the denominator we need to factor the x, and then we have the 2x squared minus, I'm sorry, there's no 2, so there should be x squared only. So there should be x squared minus 2x plus 5. So basically, this is now already in the form of ax squared plus bx plus c. Then afterwards, we can already uh, decompose this one or divide this into partial fractions. So we have a, and then the denominator is x, as you can see. And for this equation, if you try to find the roots of this one, this is not a perfect square, so maybe say it will yield to an unknown factor. So meaning to say we can also assume this partial fraction here. So we already have our a here, so we can just start with b. And this is our a, and this is our b. So meaning to say, this is 2, and then our a is 1. So just put x here for this one. And then our b is negative 2. So that is minus 2 plus c all over our denominator, which is x squared minus 2x plus 5. So now we can already solve for we can already continue to the process that we already know from the previous video. So multiplying both sides by the denominator, we have x times x squared minus 2x plus 5. So what remains here is 2x squared minus 5x plus 10 is equivalent to a times x squared. So we have our a times x squared minus 2x plus 5 plus our b, which is multiplied by 2x minus 2. So we have 2x minus 2, and then the remaining term here is just the x plus our c, and then the x, because this can be cancelled. Now afterwards, simplifying our equation, we have 2x squared minus 5x plus 10, which is equivalent to ax squared minus 2ax plus 5a plus this one, 2x times x, that's 2x squared times b, so we have 2bx squared minus 2bx plus our cx. Now, afterwards, we need to find the value of our a, b, and c. So in this case, we can use, in finding our a, b, and c, we can use the coefficients of our exponents. So by coefficients of x squared, we have 2 is equivalent to a, then we have the 2b, then that's it for the x squared. So for now, we'll move on to the coefficient of our x raised to 1, or of our variable x. So we have negative 5, which is equal to negative 2a minus 2b plus our c. Now continuing, we also need to find the coefficient of our constants, which is equal to 10 is equal to 5a. So since there's no other constants here, I think it's very easy to solve for the value of our a. We just need to divide both sides by 5 to isolate our unknown constant a. So meaning to say our a is equivalent to 2. So from our first equation, this one, we can already substitute our value of a here to find the value of our b. So basically, we have 2 is equal to 2 plus 2b. So 2 minus 2, that is 0. 0 divided by 2, we have b is equal to 0. Now for the value of our c, we can just plug in or substitute the value of our a and b. So we get negative 5 is equal to negative 2 times 2 minus 2 times 0 plus c. So basically, the value of our c is negative 1. So we already have the value of our b, a, and c. So we can already plug in our values for the unknown constant numbers here in our partial fraction. But we have to note that we still have our integral of dx here, and this partial fraction is just for the second integrand. So we just have to copy our integral of dx as well. And then now we need to replace our a by 2, which is 2 times dx over x, which is the denominator of our a. And then for the b, that is equivalent to 0 times 2x minus 2 all over our denominator, which is x squared minus 2x plus 5 dx. Now we also have our c, which is the denominator of our c is x squared minus 2x plus 5. So since our c is negative 1, so we need to replace that by negative sign. And then we have the dx over x squared minus 2x plus 5. So now we can already integrate this one. So the integral of dx, we all know that it is x plus the integral of dx over x, that is 2 ln of x. And for this one, 0 times any number, that is 0, so meaning to say we can cancel this term. And for this one, as you can see, if you try to solve this one, this is not a perfect square. So we need to find, or we need to solve this one by completing the square. So in completing the square, we need to find the value of our b, which is the negative 2, divided by 2, which is negative 1, and then square the number, so we have 1. So basically, we have x squared minus 2x plus 1 is equivalent to negative 5 plus 1. So if you try to factor this one, that is equivalent to x, minus 1 squared, and then this one, negative 5 plus 4, that is plus 4 if you transpose that to the other side of our equal sign. So we already have this one. So basically, we can replace that with dx over x minus 1 squared, and 4 here can be replaced with 2 squared. So basically, this term, or this denominator here, is in the form of arctangent, if you can still remember. So basically, this is our u, and this will be our a. So we have now x plus 2 ln of x minus our arctan, that is 1 over a, arctan of u over a. Now our u is x minus 1, so we have 1 over 2 arctan of x minus 1 over 2 plus c. So basically, we now have our final answer. So I hope you learned something from this video, and please feel free to comment down below for any clarifications or questions, and you may also reach me in our LMS, in our Blackboard, and I will be pasting here the much clearer answer for this example for your reference. Thank you so much for listening. Thank you so much for watching, and I'll see you on the next video. Goodbye.